So hello everyone, so this is Yang Yifan. I'm your tutor for MA1505 for group A3 and D9. So once again, I need to apologize for that I didn't turn up in today's tutorial class. I will make sure that this won't happen again. So if you have any problem about the questions in tutorial 1, you can contact me through my email address. I will attend to you as soon as possible. So okay, let's start. I'm really looking forward to see you guys in the next week, next Tuesday, okay? So see you then. But I'm gonna finish this tutorial first. So in this tutorial 1, we are mainly talking about the calculation of derivatives. I'm sure that you already know the importance of derivative of functions. You can get a lot of information of the function from these derivatives. Otherwise, you have to calculate the value of function at each point, which will be really troublesome, okay? So that's why we need to calculate this derivative. So the first question is about the composition of two functions, g of f and f of g. So first question, f of g minus g of f. Is this correct? Oh, yeah, x. So we need to calculate this one. Maybe probably I don't use this one. I just directly write here. Minus g of f of x. Oh, I'm sorry, this is the first time that I use this to record a tutorial class, so apparently there's a mistake here. But anyway, this will be simpler. Okay, so this is a question. So for the composition of two functions, from the name of it, because we know that f of g of x is just equal to f of gx, right? Now that we already know that the expression for g, which is square root of 3 minus x, the absolute value of 3 minus x. So this we just plug in, right? So this is f of square root of 3 minus x. And we plug in the expression for f, because fy equals to 6 over y. So the reason why I use a different variable here is to make sure that you won't get confused, because y here equals to square root of 3 minus x, right? So this will be 6 over square root of absolute value of 3 minus x. So that's it. Pretty simple, right? And similarly, we can calculate the g of f of x, which, okay, so once again, write down this one in the form of g of fx. So the input of g is now the result of f, which is, okay, so plug in here, f is here. So this will give us 6 over y. Oh, not y, x. So what's this? This is just a square root of absolute value of 6 minus x. So if we plug in, you can find the right answer out there. Pretty straightforward. So this is just for you to get familiar with this composition of two functions. And okay, so much for this one. So for the second question, we need to calculate some derivatives of functions. And okay, so for the first one, y equals ax plus b over cx plus d. Okay, so for this one, apparently this is a quotient, so we can directly use the quotient rule. Okay, so okay, we use fx as ax plus b and gx as cx plus d. So what's y? Y just equals to f over g, right? So according to the quotient rule, y prime equals to what? Think about it. G squared. Okay, f prime times g minus g prime times f. All these derivatives are at the point of x, are taken at the point of x. So f prime equals to just a times g, which is cx plus d, minus the derivative of g, which is c, times fx, which is ax plus b. G squared, okay, so cx plus d squared. So what's this? Actually, you can leave it here, but of course you can simplify it, because you can see there's a cx here, and there's another acx here, so it can be cancelled off. So we will get ad minus c times b over cx plus d squared, right? So pretty straightforward. This is the simple application of the chain rule. Okay, so for question B, y equals to sine to the power of n x times cosine mx. Okay, so the framework of this function is a product of two different functions, right? So if we regard this as f and this is g, so this will be f times g. So we can use the product rule to calculate this one. Okay, so we just write down, which means y prime equals to f prime times g plus g prime times f. So now the problem will be, what's the derivative? What's the first derivative of sine to the power of n of x, right? So for this one, once again, we need to use the composition rule. This is a composition of two functions. Okay, I'll just write down here, since we have plenty time here, because if you are in a hurry, you can always skip those parts you already know, right? So I will write down in details. So f, this is sine to the power of nx prime times cosine mx plus cosine mx prime times sine to the power of n x, right? So I will add a page below, right? Yeah. So let's see. So okay, I will write down in details. So our question will be, this one is what? Okay, we use the composition rule. So now we take this as two functions. Let's see, what do we use? Of course, this is a composition of sine of x and x to the power of n, right? So there are two functions here, x to the power of n, and another function. Okay, let's say f equals to f1 x equals to sine x, and g1x equals to x to the power of n. So sine to the power of nx is just equal to what? Just equal to g1 of f1x, right? So it's just a composition of functions, so you can write down in this form. Pretty simple, straightforward, right? So the derivative of this one, okay, so the prime of this one is just equal to g1 prime at f1x times f1 prime at x. So g1 prime, what's this one? Okay, see, g1 prime x is just equal to n times x to the power of n minus 1, right? So what we have here, oh, I'm sorry. You see, this is the derivative of g1 at the point x, but now we are at the point of f1x, so we have to replace this x by f1x, right? Because this is our input. So I'm going to erase this one. f1x equals to sine x, so this will be right. That's simple. And times f1 prime at point x, which is just cosine x. So we have the answer for this now. this is just n times sine to the power of n minus 1 x times cosine x. Right? So this is for the first part. So this is for the first part, and the second part is here. Okay, let me see. Second part is this one. Cosine mx prime. What's this one? Okay, again, you can write down f2x as cosine x, and here we have, here it's not x, right? It's m times x, so probably you want to introduce another function g2x, which is equal to m times x. So cosine mx equals to what? It's just a composition of f2 and g2, so it's f2 circle g2 of x. Now you can plug in to verify this one. So now the problem is easy. You just write down the derivative of this composition. So this one is f2 prime at the point of g2x. Okay, remember this is a chain rule. I'll write down here. You can check this later in your textbook, or yeah. So times g2 prime x. So what's f2 prime? The derivative of f2 is just minus sine, right? Originally should be x here, but now our input is g2x, so it's g2x. But we can plug in here right now. So g2x is just equal to mx. So I'm going to write down mx times g2x. g2 prime x is just m. So we got it. So the answer is minus m times sine mx. So now we have the answer because we plug in to the original product rule. So we get the y prime equals to f prime equals to m okay, once again, the g prime times f is equal to this one, so this should be minus here, minus m times sine mx, right? So straightforward. Okay, this is question B. Oh, I'm sorry. No wonder I feel strange. You see, this is just f prime, and this is just g prime. So we have to times f and times g here, right? So the right answer will be f prime, which is here. F prime is here. Okay, f prime is here. So this is just equal to m times sine times g, which is cosine mx minus g prime, which is here, times m, and times f, which is sine to the power of nx. Now it's correct. Yeah. So you see how we do this. Okay, first we use the product rule. in the first place. So we decompose this into two functions, f and g. So we can use the product rule, and later we have to find the derivative of f and the derivative of g. So once again, we have to use the chain rule, right? Because this f is not just a simple function. It's actually a combination of two functions, which is sine x and x to the power of n. And similarly for the function g, it's also a combination of two functions. So once again, you can use the chain rule. But later, if you get familiar with this, you can skip those parts here. Okay, you can skip those parts. Once you get familiar, you can just write down the derivative directly. This is for you to understand how we calculate the derivative with this chain rule. Okay, so this is question B. Okay, let's add a page below. It seems that we have to accelerate. We don't have too much time left. Okay, so this is at page below. So this is C, which is y equals to exponential of x squared plus x cubed. Okay, this one is simple, right? Because this is apparently a combination of two functions, right? Because exponential of e to the power of x, which we are quite familiar with, right? And x squared plus x cubed. This is just a polynomial function, which is pretty simple. So if we take this as f and take this as g, so what's this? Y will be f of g, I'm sorry for that, f circle g, or f of g at x, right? So if we use the chain rule, what we get is y prime at x, of course, it's just equal to f prime at gx times g prime of x. So we'll just plug in, because f prime is just ex, doesn't change, right? Because this is a exponential function, and g prime is equal to 2x plus 3x squared, right? So we just plug in, okay? Okay, sorry, this is f prime, which is e. Okay, remember, this is a function. F prime itself is a function, which is e to the power of x, but now the input of is gx, so it should be gx here, but since we already know that gx equals to x squared plus x cubed, so we can plug in it here or later, so it doesn't matter. So we leave it here. G prime of x, which is 2x plus 3x squared. So this will give us exponential of x cubed times 2x plus 3x squared. Right? I hope I'm correct. Yeah. So this one is simple. So for question D, problem is x cubed minus 4 times x squared plus e squared plus ln 2. Okay, as we know that a derivative of a fixed number is what? It's just 0, right? The derivative of a constant is just 0. Okay, so okay, this is not prime, this is just y. So this equals to x squared minus 4x2 plus a constant. We don't care about what's the specific number here. We don't care about. As long as this is a constant, we don't care about it in the calculation of a derivative. Okay, so constant, you can just denote this as C1. Okay, maybe I should write down C1. Just C, okay, which means this is a constant. So the prime of y is just 3x squared minus 8 times x plus 0, right? That's the end. We already got the derivative, so we don't care about the constant parts. So let me see. what we have left. Okay, so for this e, y equals to sine theta over cosine theta minus 1. So now the variable here is theta, okay? Okay, so actually this one is kind complicated, you see. First we have composition here, which is x squared, and because apparently there's a composition here, x squared. So first of all, we're going to write down y prime equals to 2 times sine theta, this is a chain rule of course, times the derivative of this function. See? Okay, so you see, now we need to calculate the derivative of this one. How do we do this? Of course, we can use the quotient rule, right? So it will be straightforward. You can finish this later yourself. So the final answer will be, okay, you can check this later in the solution set, but I will give you the answer here, which is minus 2 times sine theta times cosine theta minus 1 to the power of minus 2. Okay, so that's it. That's question E. It's for question D. F, actually F, not D. Okay, so what's F? F is here. Y equals to t times tangent of two times square root of t plus 7. So once again, there's a constant here, so the derivative with respect to 7 is just 0, so we can you can skip that part. So y prime equals to, first we use the product rule, so this will give us tangent. So because the derivative of t is just 1, so we skip that part, we ignore that part. So later we have is t times, so tangent, right? So you see we have to calculate the tangent, the derivative of this function, which is tangent of 2 times square root of t. So this is another commutation. You have to commutation, okay? So you have to use the commutation rule. So for this part, which is equals to, okay, so the first part is f prime, which is tangent prime at square root times, right? So what's this one? What's the derivative for tangent? Still remember this, right? Because tangent equals to sine x over cosine x, so you can use the quotient rule to get equals to plus, and this is just 1 over cosine square x, so this will be times, okay, so what's this one? This is just, so if we plug in, we can get the right answer, which is tangent of 2 times square root of t plus, which is, okay, so remember, this is t times this one, t times this one, so this will give us square root of t times cosine minus 2 of right? Yeah, that's it. Or you can just denote this as SEC square of x. Okay, that will do it. Okay, so that's for question F. What's the next one? Okay. Let me see how much time we have used. Okay, 25 minutes. Okay, I will speed up. Okay, so okay, so it's here. No, it's here. Sine of theta plus square root of theta. So you see, this seems really strange, this function. Okay, we have no idea how this will behave, right? So that's where we're gonna use the derivative. Okay, so we just calculate the derivative. Of course, this is a conversation. Okay, so okay, once again, I will do this in this form: fx equals to sine x, and g theta equals to theta plus square root of theta plus 1. Okay, is this correct? Yeah, that's correct. Check again. Yeah. So the function r will be f circle g at theta, which is just f of g theta. So if you use the chain rule, you will get f prime at the point g of theta times g prime at theta. So f prime just cosine, right? So cosine g theta. So we can plug in the expression for g theta later. So we leave it here times g prime theta. Okay. So from this one we will get g prime theta is just 1 plus, right? So this is 1 plus 2 square root theta plus 1 to the power of minus 1. Okay, so that's it. That's the r prime. Of course, we haven't plugged in the expression for g theta. We can do this right now. So this is cosine theta plus 1 times. We can simplify this one. So it will give us right. So that's the answer for G. Okay, we have to add our page below, right? So for this question, what's S equals to 4 over cosine x plus 1 over tangent x. Okay, so S equals to okay, so if we regard this as f and this is g, so we know that s prime equals to f prime plus g prime. This is straightforward, right? So for the f prime, f equals to 4 over cosine x. So definitely we can use the quotient rule, right? We can use the quotient rule. So this will give us f prime equals to cosine square x. Still remember the formula for quotient rule? If you don't remember, you can check this later. Okay, so minus, oh, actually this will be 4 sine x. Okay, that'll be it. And what's this? This is just 4 times tangent x, because sine x over cosine x is just tangent x. Or you can just leave this, just leave it here. You can stop here. Okay, over cosine x. So this will be, because 1 over cosine x is just SECx times, okay, that'll do it. And g prime, what's g prime? Okay, G. Okay, G is here. G is just tangent x. So this will give us G prime. Again, once again, you can use the chain rule. Okay, so maybe you shouldn't use this. I don't know what which one you prefer. Okay, I'll just write down what I'm familiar with. Okay, so this is square over minus okay, so what's this? This is just minus sine x squared, which is cosecant, right? So that will do it. You can just use the quotient rule and leave it here if you're not familiar with these notations. It's fine. Okay, so this is okay. So much we have calculated the derivative for 8 functions. You can see we have used the chain rule many times, and most importantly, I think we have to familiar with the chain rule, because most likely we can always break down some strange or complicated functions into a composition of 2 functions or 3 functions, right? Anyway, we can if we just follow the chain rule, we can get the right derivative. Okay, so much for this one. Have a